Now, hey guys, welcome back. This is topic 8, part 2, video 3. So, this one is our last video for part 1. So, this idea is pretty much what do we do when we have long equations that needs multiple undoings. So, here's a short one. Here's an example. So, similarly, this is pretty much an example from the previous video. 5m minus 7 is equal to 8. Again, what do we do? Before we undo 5m, again, our goal is isolate m. But to do so, we need to get rid of minus 7. How do we do that? We have to add 7. Add 7 on both sides of the equation, and you'll get 5m is equal to 15. Now, to get rid of that 5, we need to divide both sides by 5, and you're going to get m is equal to 3. So now, that's a quick review on what to do on multiple steps, multiple operations. Now we're going to put in combining like terms, distributing, and undoing multiple operation into one problems. So how do we do that? Well, let's have an example. We have 2 minus 6 is equal to 5x plus 4 times everything by negative 5 subtracted with 39. First thing first, you need to simplify. You're going to distribute negative 5 to both x and 4, and you're going to get negative 5x plus negative 20. Let me write a parenthesis so you guys don't get confused. Negative 20 minus 39. Now what do we do now? Now that we're done with simplifying any distribution, what do we do? Well, now we can combine like terms. Start with the left side. 2 minus 6 can be combined to negative 4, and negative 20 and minus 39 can be combined to negative 59. Now, what do? We're going to subtract negative 59 on both sides. We're going to get 55 is equal to negative 5x. So now we want to get rid of that negative 5 of negative 5x. How do we do that? We divide both sides by negative 5. And so you're going to get 55 divided by negative 5 is equal to negative 11. And the right side will just be simply x. So your answer is x is equal to negative 11. Let's have another example. 5x minus 4 is equal to 8z plus 5. Now, first thing first, can we combine any like terms? Nope. Again, you might be tempted to combine 5z and 8z, but we can't. Why is that? Because they're on the separate side of the equation. 5z is on your left and 8z is on your right, so we cannot simply just combine them. But what we can do is we're going to eliminate the smaller variable. How do we do that? We subtract negative 5z on both sides. 5z and 5z and minus 5z is 0, so you're left with negative 4. 8z plus 8z minus 5z is 3z, and then you just bring down the 5. Now you have negative 4 is equal to 3z plus 5. Now we need to eliminate plus 5 by subtracting 5. So now you have negative 4 minus 5, which is negative 9, and 3z plus 5 minus 5 is 0, which leaves us 3z. So now we have negative 9 equals 3z, we want to get rid of that 3. How do we do so? We divide both sides by 3. Hence, you're going to get negative 3 is equal to z. So, from those three examples, when we have long equations, here's our step that you should do. You first simplify and combine like terms. What simplify means do distribution, and then you combine like terms. And then what you do is you eliminate the smaller variable. Doing so prevents negatives on our variables. If you move 5z, 8z instead, you're going to get negative 3z, and you're going to divide by negative, which is a pain in the ass later on. That's why we want positive with our variables. And then once we do so, we eliminate the smaller variable, we want to eliminate the constants. How do we do that? Well, we add or subtract, and now once we've done so, we're going to eliminate the coefficients. Again, look at your work, topic 7 for coefficients. But now let's move on to the next example. We have xr minus 7 is equal to 5 minus 3r. What do we do? Well, first thing first, we're going to eliminate the smaller variable by moving it. So, which was the smaller variable, r or negative 3r? Negative 3r. So how do we get rid of negative minus 3r then? We add 3r, and you're going to get 4r minus 7 is equal to 5. Now, can we combine any like terms? No, we can't. So what do? Well, we simply eliminate the constant. What's the constant in this part of the equation? So which was the constant in this part of the equation? Minus 7, right? So how do we get rid of that minus 7? We add 7. And since we add 7 on the left side, we also add 7 on the right side. Hence we're left with 4r is equal to 12. Now divide both sides by 4 to get rid of that 4 from 4r. Hence we're going to be left with 3 is equal to 12 divided by 4 is 3. So your answer is r is equal to 3. Now let's move on to the next example. We have 2x minus 6 times 3 plus 6 is equal to 0. And yes, equation can be equal to 0. That's okay. Some people stop right here. You can still go on even though your equation is 0, okay? Because right now our x is not by itself, so just because it's equal to 0 doesn't mean we stop. The only time we stop is when x is by itself. And we'll see that later on in the next example. But right now, what do? Well, first we need to simplify the distribution. So distribute 3 to both 2x and 6. And we're going to get 6x minus 18 plus 6 is equal to 0. Now what do? Well, we combine like terms. Negative 18 plus 6 is negative 12. So your answer is 6x minus 12 is equal to 0. Now we want to get rid of the constant. So we add 12 on both sides. So you're left with 6x is equal to 12. Now, when we don't stop here, our goal is again x by itself. So what do? How do we get rid of that 6? We divide. So we divide both sides by 6. You see right here, 6x over 6, and then 12 over 6. What is 6x? What is 6x over 6 going to be? It's going to be x is equal to 12. So your answer is x is equal to 12. So now let's move on to the next example. We have 4a minus 2 plus 5a is equals to 2a minus 2 plus 3a. So first thing first, what do? Well, we're going to combine the like terms. So we're just going to add 4a and 5a to get 9a minus 2 on your left side, and we're going to combine 2a and 3a by adding, and you're going to get 5a minus 2. So a common mistake people do when you're decombining the like terms can be seen here. So here's the example above. 4a minus 2 plus 5a equals 2a minus 2 plus 3a. What the common mistake is when they combine like terms, they think, oh, we're going to subtract 5a, and then we're going to subtract 5a here, and then you're going to get negative a. You don't do that. The only time you do you undo an operation is when you do it on the other side. So when you do these things, I want you guys to always write that line, so you know that you're not doing it correctly. Since again, I told you guys, if you write something on your left side, you also have to write it on your right side. But since you did it on both left side, you should automatically know you did something wrong. So this line is a good reminder, and I want you guys to write it when you're solving your equation. So what you actually have to do is you're just going to add 4a and 5a plus or positive 5a if you want to include the sign, positive 5a, you do 4a to get 9a, and then minus 2 is still minus 2, and just same thing you do on your right side. So now our new equation is 9a minus 2 is equal to 5a minus 2. Now what do? Well, you want to eliminate the smaller variable by subtracting 5a on both sides. 5a minus 2 minus 5a is basically negative 2, and 9a minus 2 minus 5a is 4a, and then minus 2 is still the same. Now what's our goal? We want our a by itself. So how do we do that? We want to get rid of the constant minus 2. How? We add 2. So negative 2 plus 2 is 0. So you're left with 4a. And negative 2 plus 2 is 0. So your answer is 4a is equal to 0. Now you don't stop here because we're not done yet. I have students before that stops right here. They write 4a is equal to 0, and then they don't know what to do. Well, what do? Well, our goal doesn't change. Our goal is to have a by itself. So first, one way or another, 4 has to disappear. How do we undo 4? How do we undo multiplying by 4? We divide by 4. 4a over 4. 4a divided by 4 is a. And since we divide the left side by 4, you have to divide the right side with 4. Now, what is 0 over 4? What is 0 divided by 4? It's 0. So that means we can still divide this. 0 divided by 4 is 0. So your answer is A is equal to 0. Now our last problem for this part is this 6 minus 3x minus 1 times 2 is equal to 3 minus x times 3. Add with 5. So first thing first, we want to simplify in command like terms. Since the last example, we're going to do it step by step. We're going to distribute negative 2, not just 2, negative 2. You have to include the sign in front of it to both 3x and 1. So it's going to be negative 2 plus 3x, negative 2 times 3x minus, it's still the same operation, negative 2 times 1. And then once you simplify this part, you're going to get 6 minus 6x plus 2. Now that we're done with distributing on your left side, let's distribute on the right side. Now in this case, we're going to distribute 3 to both 3 and x. So you're going to get 3 times 3 minus 3x plus 5. Now simplifying this, you're going to get 9 minus 3x plus 5. Now that we're right here, what do you think we should do? You should do is you add any like terms, combine like terms. So what is a like term with 6? Well, it's 2. 6 plus 2 is 8. So you're going to get 8 minus 6x. Now, what is there any like terms on the right side of the equal sign? Yes, it's 9 and 5. 9 plus 5 is 14, and then you just copy 3x minus 3x. So it's going to be 14 minus 3x. Now that we're right here, what step should we do? Well, you should eliminate the smaller variable. So now we're going to figure out which one's smaller variable, negative 6x or negative 3x. We're going to get rid of which one is the smaller variable, which smaller term. It's negative 6x. So we're going to ask, how do we undo negative 6x? How do we move any term from left side to right side or right side to left side? We undo it. We do the opposite operation. We undo the operation. In this case, we're subtracting 6x. So what undoes subtraction? Addition. So we had to add 6x on your left side, and hence we also add 6x on your right side. So you're left with 8 on your left, and then negative 3x plus 6x is 3x, positive 3x. So your term should be 8 is equal to 14 plus 3x. And now what's our goal? Our goal doesn't change. Our goal is to isolate the variable, in this case is x. So now, variable there. So now we want to get rid of 14. We want to get rid of the constant. How? Well, we're going to subtract both sides by 14. So let's start with this side. 14 minus 14 is 0, so we're left with 3x. And 8 minus 14 is negative 6. So the answer is negative 6 is equal to 3x. And now what's our goal in this side? We eliminate the coefficient. Which one's the coefficient? Negative 6 or 3? 3 is the coefficient. So how do we get rid of 3? We divide both sides by 3. So 3x divided by 3 should give you guys x. And negative 6 divided by 3 is negative 2. So your answer is and that's it for this recording, this part. Stay tuned on equation 2 part 2. Equation part 2, not equation 2 part 2. Anyway, this is our lecture for today.